Hello everyone and welcome to this video on automatic picture transmission or APT signals. In this video first we will see what is APT signal, then we'll demodulate and decode the signal using MATLAB and Simulink. APT signals are simply a satellite image signal that can be used for weather applications. So let's get started. First we'll introduce APT signals, then we will see how these signals are transmitted. Then we'll see how we can receive the signals. Then the interesting part that we will show you a demonstration using MATLAB where we can demodulate and decode the signals and extract the satellite image. And finally, the conclusion. So first, what is APT signals? APT signals are simply signals that are transmitted from satellites, like for example, an OAA 15, 18, and 19 satellites. These are polar orbiting satellites that's orbiting the Earth. And when these satellites pass overhead or pass over us, we can receive the APT signal and extract the image. So let's see how the APT signal is structured. So the signal is structured as frames. In each frame, we have 128 lines. As we can see here in this figure, the signal structure. Each line has a duration of half a second, and each line contain actually many things. First, it contain a sync signal, so uh, it contain a sync signal, then some spacing signal, the channel A signal. These actually the data or the pixel of the image. Some telemetry signals. These signals has data about the satellite, the temperature, the mode of operation, and so on. Then sync signal also, some spacing signal, and other pixels or other data for other image. So actually, APT signals contain two images, not one image. Contains typically two images, one visible light image and one infrared image. So in each line, we have the information about the first image and then the second image. After that, we have also some telemetry signals about the second channel or the second image. So it's typically APT signals has two image A and image B. They are called channel A and channel B. And the information or the image is divided to lines. And in each APT signal line, which is a half a second, we have the pixels of image 1 and image 2, as we can see here. So let's see how each line is further divided. So each line, as we said before, it has a sync signal, sync A, and sync B, sync signal for line or for channel A and for channel B. We have some spacing signal that we can know where each frame starts and ends. And the pixels are, it's called words here, data. Each word is actually the information about the pixel in the image. Then we have the second channel, which is here called channel B, and it has the information about the image B. Channel B also start with sync signal. We have some spacing, and then the words about the pixels or the here it's called the channel B words or channel B pixels. And finally, also we have the telemetry data. This figure shows us how it's called each data point or each pixel is called words. And it shows us, for example, how many words we have in the sync signal, how many words we have in the spacing, and the data signal or the pixels, and so on. So we can know the timing of each line. How the data or how the pixel information is encoded, we have a BW image, black and white image, that it's pixel divided between 0 and 255. So we have, as we can see here, for example, we can assume that this is uh, some words about the, for example, channel A or channel B. So each word has a value between 0 and 255, which contain the information about the image or the information about the pixel, the value of the pixel. So, for example, if we know that each line has 2080 words, and its duration is half a second, so we can know the duration of each word, which is typically this duration. This information is important, and we will use it in the demodulation and in the decoding. So what are the sync signals? We have two sync signals, one before image A or channel A and one before image B. This sync signal has some unique pattern of zeros and ones with a predefined timing, as we can see here. So we can see the one duration and the zero duration is 2t, or has a duration of 2 words. So this unique pattern that is 39 word long, we can use it to synchronize the frame, so we can know where each frame starts, or where actually each line starts. This is very important, so we can extract the word data. So we will see at the receiver that we will synchronize the received signal. So actually, by correlation with the sync signal, so we can know each line where it starts, so we can do the demodulation, or actually the decoding, and extract the information of each word. So this is the sync B. Uh, we can see that it has also a unique pattern of zeros and ones, and this can be used also for demodulation or for decoding, so we can extract the information of the images. So how the signal is transmitted? So the signal first, the raw data of the information or of the images and the synchronization uh, uh, signals and the telemetry are first amplitude modulated with a carrier of 2.4 kilohertz. This is amplitude modulation with large carrier, as we will see in the demodulation part or the demo part. Then this signal is modulated at a frequency of 137 megahertz and then transmitted by the satellite. So first the signal is first amplitude modulated and then frequency modulated and then transmitted at this carrier frequency. So if we are at the receiver, we will receive the signal. First, we have to do the frequency demodulation and the amplitude demodulation. Then we'll extract the raw data, and then we'll do the decoding so we can extract the images from the raw data. So let's see the demo, and let's demodulate and decode a real APT signal. So in this video, we will see the demonstration and how we can demodulate and decode the APT signal and extract the images. So actually, we have two parts. First, we will do the demodulation using Simulink, and then we will take the raw data and do the decoding using a MATLAB code. So let's see the demodulation. So this is simply the Simulink model that take the APT signal, the received APT signal directly from APT or an OAA satellite. We'll do the demodulation, first the frequency demodulation, then the amplitude demodulation, and finally it will send the raw data to the workspace. So we can use a MATLAB code for the decoding. So first, the input data, we have this pre-recorded APT signal recorded at this sampling frequency. This signal actually was downloaded from this website. This is the APT signal from an OAA 18 satellite. We will use this signal in the demodulation. Then this actually carrier signal that we can use to correct the Doppler shift. But here, as we will see, I have it at zero frequency, so it actually does not do anything. But you can use it uh, to to correct Doppler shift. But we will see that actually the frequency or the Doppler shift does not affect the image that much. Then this is the frequency demodulation. It's actually a discriminator circuit. Take a complex baseband signal and give us a real signal that is frequency demodulated. Here we change the sampling frequency. The sampling frequency is actually too much, so we change it by using decimation, by dividing the number of samples by 5. So we have a sampling frequency of 12.5 kilohertz. Then we will do the amplitude demodulation. The amplitude demodulation is simply we take the input signal, square it, so we will have a signal at zero frequency and a signal at double the frequency at actually 2 Fc. Then we take a low pass filter and take the absolute value and the square root, which is simply mean that we are taking the envelope of the signal. Then we will have a raw data, a raw APT data that we'll use in the next step in the decoding. So we can synchronize for each line and extract the image data. So let's run this code actually to see the results. So if we run the code, we will see this is the received signal spectrum, and this is the spectrum after the frequency demodulation. So we can see, for example, in the received signal, we can see that this is an FM signal that has this number of side bands. If you studied FM signal before, you know that it has a number of side bands that depends on the frequency or on the modulation index. So this is actually a frequency modulated signal. If we do the frequency demodulation, we will have an amplitude modulation or an amplitude modulated signal. If you remember, we said that the AM signal is modulated with a carrier at 2.4 kilohertz. So we can see here that we can see the carrier frequency at 2.4 kilohertz, and we have the signal modulated to the upper sideband and lower sideband because this is double sideband large carrier amplitude modulation. So the signal after the amplitude demodulation is sent to the workspace, so we can use the MATLAB code to do the decoding. So we have this MATLAB code. First, we define the sampling frequency. We take the input data from the workspace and other parameters related to the APT signal. So if we run this part using Control and Enter, then we have this second part that generate the sync signal. Actually, we are synchronizing our line only to the sync A signal, which is the first sync signal, and then we take the words data after that. So this is actually the sync A signal. If you remember it from the video, we will use it so we can synchronize to the beginning of each line. So in the synchronization part, if we run this part, what we are doing is we are taking the correlation between the sync signal and the received signal. So each peak that you can see, this is actually the beginning of a line. So this is the beginning of a line, this is the beginning of the next line, and so on. After we know the beginning of each line, what we can do is simply to sample the line at duration of word or t as we defined it in the video. So this part is simply taking each line and sample it at duration of t, or take a 2080 samples from the line. So if we run this part, we are extracting the information of each line and saving it at this line matrix, and then here we can see the received image. Finally, this is the received satellite image. As we can see, we have two images. This is image A and image B. Image A is visible light image. Image B is an infrared image. So we can see this is the spacing that divide each frame. So this is a frame, this is the next frame, and so on. Each frame actually has 120 line. So we can see first, this is the sync A signal. This is the spacing. So we can know this is or where each frame ends and the next starts. This is the image, the visible light image, and this is the telemetry signal that has some information about the satellite, the mode, and so on. This is the next channel. We have also a sync signal, signal that separates where the each frame starts, the image, this is the infrared image, and we have also the telemetry signal. So this signal actually the received signal from the NOAA satellite at the APT signal or APT standard. You can do, if you want to do some homework, you can extract the telemetry from the signals. So we only show the signals, but we can also extract the data, the telemetry data, which is are here in each line from this signal. So if you want, or you want to do some homework, you can extract this information from the image. So in conclusion, this video first introduced APT signals, how the signals are structured. Then we saw how the signals are transmitted and what are the modulations that are used in the transmitter. Then we saw how we can receive and demodulate and also decode the signal and extract the satellite images. Finally, we saw an implementation of the demodulation and the decoding on real APT signal. And we actually extracted the satellite images from the signal.